Hello, students, and welcome to today's Friday Happy Hour. This is our first happy hour for the semester, which is a mini semester. Today, I'm going to cover how to navigate through Mymathlab, graph linear equations, writing equations, parallel lines, perpendicular lines, linear models, evaluating functions, and quadratic equations. This will prepare you for exam number one. Okay, so let's start with navigating through Mymathlab. To navigate through Mymathlab, so you can actually get access to the platform Mymathlab, you're going to go to www.mymathlab.com. Once you click on the link right on your computer on the internet, it's going to take you to this page here. Then you're gonna, if you're already registered and have an account, you're gonna sign in. But most students, they haven't registered to the class. So what they're going to do, they're going to go here where it says student, right? They're going to click there. If you don't have an account, you're going to go to student. You click there. And then once you click it, it's going to take you to this page here. There are three things that are required. Once you have one through three, right? Which means your email address, your instructor's ID course, an access code or credit card or PayPal. Once you have 1, 2, and 3, you're going to go ahead and hit OK, register now. Once you do that, it's going to take you to this page or to something similar because I believe Mymathlab was updated. But this is something similar or maybe the exact thing, but it was updated last semester. So anyway, here's where you're going to click the ID course, which your instructor will give you the ID course. Once you put it in there, right, I believe this was my ID course for for last summer or 2 semesters ago. Once you click in it, right, you're going to hit continue. Then it's going to take you here, right? If you already have the account, right, you go here, but to create an account, you're going to hit create. Right, you're going to hit create here to create the account. And here it tells you, right, that you're in the right course, right? This is Math 1324, the course ID, and this was the course ID that I entered, and this is my name, Mr. Isasi. Oh yeah, this was from the fall of 2021. So you're going to hit create. Once you hit there, it's going to give you something like this or something very similar where you have to fill in all these empty boxes. So all these are required, right? Your email address, and they prefer for you to use your EPCC email. You're going to create a username, a password. They're going to want you to re-enter the password, right? Then you put your first name, last name. Then there's always a security question for security purposes, and that answer. And then you're going to hit agree. I agree to the terms of use and acknowledge of the privacy policy. After you do that, right, all you can do is hit create. Once you do that, it's going to give you an option, right? An option to buy the code, right? You can pay 104, which is for up to 24 months. You click there, right, and then you pay with a credit card, or you can buy the one for $69.99, which is an 18-week course. And say you don't have any funds at the moment, you can get here the temporary access code here at the bottom. You hit there at the bottom, right? Once you click in there and you have access to Mymathlab, this is the way it's going to look, right? So you're going to click assignment, right? Because you're going to start with the assignments. You're going to click assignments, and it's going to take you to here, right? Assignments to 1, to 2, whatever the instructor has already set up for you. So say you click assignment homework number 1 to 1, right? These are the problems here, guys. So then say that I click on question number 1. This is 2.1, chapter 2, section 1, and number 1. So here, guys, I believe, like I said, Mymathlab is similar to this, but it has assistance. For example, if you click here, you can have question help. They can help you solve this problem. They can assist you. You can see an example. At times, there's also videos, And if not, you can ask the instructor for help, and then the instructor will get an email from Mymathlab that you need some assistance. Okay, but the most important thing for today, guys, is to get you logged into to Mymathlab, and hopefully you already are registered and doing your homework, because if not, you already missed a whole week of class, which is like equivalent to like 3 weeks. Okay. So anyway, guys, like I said here, I went over enough information to get registered and begin working on your assignments, which is the main objective for the first week. Okay, but there are many more tools, helpful tools to assist the student. But since we only have like an hour to go over the like 3 weeks, this is like for 3 weeks, because this is reviewing for exam number 1. So let's get started with the first topic of today: graphing linear equations, graphing by plotting points. There's like 2 or 3 different ways to graph. One of the ways is by plotting points. Another way is by graphing in the slope-intercept form. And the third way is by finding the x and y intercept, which I'm going to show you here in this on this workshop. Well, to start off, they want you to graph y equals to negative 2x plus 3 by plotting points. It only takes 2 points to graph, but I believe some instructors and also Mymathlab, they want you to set up a table with more than 2 points. But like I said, you only need 2 points to graph. Okay, so here, guys, what are the wise choices to use for x? Because you're going to plug in values for x. You're going to choose values for x and then plug them in for y. So it's always good to use small numbers or small integers. For example, I'm going to use negative 1, 0, 1, and 2. But you can use any number that you want. Okay, but my opinion is to try to use smaller numbers, smaller integers. So now, when when x is negative 1, I'm going to plug in the negative 1 where the x is. And all you do is just evaluate or simplify. So negative 2 times negative 1 will give us a 2. And 2 plus 3 is 5. So when x is negative 1, y is equal to 5. So what's the order, what's the order pair? Or what's the point? The point has an x and a y. The point will be negative 1, 5. And these are the ones they're going to be plotted on the graph. Now, when x is 0, we repeat the same process. We're going to plug in 0 where the x is. So this will give us 0 plus 3, so the answer will be 3. So when x is 0, y is 3. So my order pair will be 0, 3. Now we're going to evaluate it at 1. So we're going to plug in 1 for the x's. So negative 2 times 1 is negative 2. Negative 2 plus 3 will give us positive 1. So when x is 1, y is also 1. And the order pair will be 1, 1. And finally, we're going to evaluate at x equals 2. So when x equals 2, we plug in 2 for the x. It's going to give us negative 4 plus 3, so the answer will be negative 1. So when x is 2, y is negative 1. And the order pair is 2, negative 1. Now we're going to plot all these points in our graph. We start out with negative 1, 5. So negative 1 is negative 1 on the x-axis, and it's going to go all the way up to 5 on the y-axis. So that's my point, negative 1, 5. And then 0, 3, we plot it. 1, 1, we plot it. And 2, negative 1, we plot it. And we draw a line through all those points. And now remember, you only need 2 points to graph. For example, if I would have used negative 1 and 0, I would have had these 2 points. So I would have connected them. And if you notice, all these points are in the line, because here is where we evaluated all these points, all the values for x to find the y. But I repeat, you only need 2 points to graph. Okay, now this is graphing linear equations in the slope-intercept form. If a line has a slope m and a y-intercept b, then this graph of the equation will be y equals to mx plus b. This equation is called the slope-intercept form of the equation of the line. So here, guys, my m is my slope, and my b is my y-intercept. The B or the y-intercept is your starting point when graphing, and you start at 0b. So whatever the B is, you start at 0b. That's the point. And here, guys, is where the slope is. The slope is change of y over change of x, which is y2 minus y1 over x2 minus x1. That's my slope. That's my m, or the rise over the run. All these, the slope, all these are different notations for slope. Okay. Okay, now let me show you 4 different graphs. You always read right like a graph from left to right. So this is going up, so this is positive slope. This will be y equals to mx plus, this can be plus or minus b because the b is a y-intercept. But the slope, the m, will always be positive. This will be negative slope, which the m will be negative, and the b can be positive or negative. It doesn't matter. But what matters is that the slope is negative, the m is negative. This is considered, if the line is horizontal, it's going to be 0 slope. Right? It can be positive or negative, right? The horizontal line is going to be 0 slope. And the equation will be y equals to b, or y equals to a number. Okay, this is a horizontal line. And b will be a real number. It can be any number. In similar fashion, right, a vertical line is called undefined slope. So the equation of the line is going to be x equals to a number, or x equals to c, and b and c are real numbers, which means x will be, for example, this will be x equals 3, y equals 3, and the one on the right will be x equals to positive 4. That will be the line. Okay, now, let's graph y equals to negative 2x plus 3, the same one as before, but let's graph it using the y equals to mx plus b form, which is the slope-intercept form. So to graph it in this form, I need to find my m, and I need to find my b. Right, my m is negative 2, which will be 2 down and 1 to the right. From where? From my starting point. My starting point is my b, which is 3. It's also the y-intercept, so my b is 3. That means we start at 0, 3. Okay, so let's get our graph here. So 0, 3 is my starting point. So we're going to go plot 0, 3. So it's going to be up here, 0, 3. Then we're going to go down 2. Let's see here, 1, 2 down and 1 to the right. And we connect the dots. Connect the points. So that's my line. Okay. Let's do another one. Y equals to 3x minus 5. So we have to find my m and my b, right? My m is 3, which would be 3 over 1, right? Because you put it into a fraction or into a rational number, which 3 can be written as 3 over 1, which means it's going to go up 3 and 1 to the right. From where? From the y-intercept or my b. My b is negative 5, so my y-intercept will be 0, negative 5, and that's my starting point. So we'll start at 0, negative 5. We're going to go up 3, 1, 2, 3, and 1 to the right. So the point should be here at 1, negative 2. And then all we do is connect the 2 points. That's my line. Okay, now y equals 4. So y equals 4, right? We know that the slope there, the slope is going to be 0, right? Because there's no x. So my slope is 0, and the constant, which is my 4, is going to be my b. Right? My b is 4, so it's going to be the y-intercept will be 0, 4. That's my starting point. But if you notice, since we have 0 slope, the line will be horizontal at y equals 4. So we connect, so we draw a line there where it's y equals 4, right? Or you can pick another number for y. You can pick 1, 4. You can pick 3, 4. You can pick anything that the y value from the order pair is 4. That's why it's going to be a horizontal line. Now this is the observation, guys. When the equation is y equals to a number, I put the number sign because a lot of students they get confused when there's too many letters, too many variables. That's why I like to put the number sign instead. So that way everybody understands what's going on here. So again, observation, when the equation is y equals to a number, the horizontal line, there will be a horizontal line at that number. For example, y equals to 4, right? So the horizontal line will be at y equals 4. Now, let's graph x equals -2. So again, solution. Find the slope. The slope will be undefined, right? Because it's a vertical line. So then, the vertical line will be at x equals -2. So we have -2. So all the values for x are going to be -2. So my line will be vertical at x equals -2. Okay. So what's the observation here? Observation. When the equation is x equals a number, the vertical line will be at that number, at x equals -2. Okay, now, number 6. They want you to graph -5x minus 2y equals to -10. So first of all, we have to put the equation into the slope intercept form, into y equals to mx plus b. Right, so we have to rewrite it in the proper form. So to start off, we want to isolate the y, have y equals to something, right? So the first thing we do is we're going to add 5x to both sides to bring the -5x to the right side. So we add 5x to both sides. So we're going to get -2y equals to 5x minus 10. Then we divide every term by -2, or both sides by -2. So we're going to get y equals to -5 over 2x plus 5, because -10 divided by -2 will give us a +5. So now we know what the slope is, right? The slope is -5 over 2, which means it's going to go 5 down and 2 to the right. From where? From the y-intercept, which is my b, which is 0, 5, and that's my starting point. So we start at 0, 5, so we're going to go 0, 5 up here. Right, then we're going to go down 5. Let's see, 1, 2, 3, 4, 5, and 2 to the right. 1, 2. There's my point. We connect the points, so that's my line. Okay, now we're going to write linear equations from these following graphs. What's what's a line in the form y equals to mx plus b in slope intercept form? So here, guys, we know that right on number 7, we have to find my m and my b, right? That's my equation. I need to find my m and my b. So we start with the b, guys. The b is the y-intercept. So for number 7, the y-intercept is 1. So b is equal to 1. Okay? B is equal to 1. Then we have to find another point on the line that goes exactly to one of the corners. For example, let's see here, we can use the one here at 4, 4, right? Because it goes exactly to the corner. The corner, this is what I'm talking about. So we're going to use that one there. Okay. So now we're going to go up 3 and 4 to the right. So my slope is going to be 3 up, and 4 across. So my slope is rise over run, so it's going to be 3 over 4. That's my slope. So I got my b, I got my slope. Now I can write the equation in slope intercept form. So my slope is, my m is 3/4 and my b is 1. So that's my equation. Okay. Now number 8. Number 8, right? We should know that the line is this line is going to be negative because it's going down from left to right. So again, my y-intercept is going to be -2. Right? Now again, we have to find another point that goes exactly to one of the corners on the grid here. Let me see if we can find one. Let's keep going up. Keep going. Oh, it's right here. Right over the run. Right about there. Which means the rise is going to go down, right? It's going to go down all the way to where the point is on the y-axis, which is -2. Then we're going to go to the right. So if we count it, we went down 1, 2, 3, 4, 5. So it's going to be -5. And we went 1, 2, we went 4 across. So my slope is going to be -5/4. Right? Now we can find our equation because my m, which is my slope, is -5/4, and my b is -2. So all we do is plug them in. That's my equation. Now for number 9, we know that the slope, right, is 0, right? We should know that because I went over that, I think, in slide number 4. So horizontal lines is going to be y equals to, is going to be my b is negative, right? My b is -3. So my line, my horizontal line is going to be y equals to -3. Remember the observation that I mentioned earlier? So y equals to b, so y equals to -3. In a similar fashion, for number 10, it's going to be a vertical line. So the observation was vertical line at x equals to c, right? So x equals to 4. That's going to be my answer. Okay. Do you guys have any questions? If you have any questions, you can put it in the chat or just get on the mic and let me know what type of question you have, so I can answer it for you. Okay. If not, I'm just going to continue. Okay. Now, now for this part of the presentation, I'm going to show you how to graph by finding the x and y intercept. Okay. The rules are, to find the x-intercept, you let y equal 0 and solve for x. And to find the y-intercept, you let x equal 0 and solve for y. So let's first find the x-intercept. So we're going to let y equal 0 and solve for x. Right, so we're going to plug in 0 for y. They will give us -5x equals to -10. Then we divide both sides by -5. That's going to give us x equals to 2. So we plot the point, x equals 2. Okay. Then to find the y-intercept, we let x equal 0 and solve for y. So we're going to plug in 0 for x. So we're going to get -2y equals to -10. So we divide both sides by -2, and it's going to give us +5. So they will give us 0, 5. So we plot the point. 0, 5 will be up here. And we just connect the 2 points. That's my that's my graph, the line. Okay, now when I explain this method to my students, I tell them that we're going to use that we don't have to do all that work. Okay, I came up with this thing that I call the cover. I just made it up because really we cover the x, the whole x to find the y-intercept, and we cover the y to find the y-intercept, and now we can do this in our head. For example, right? So to find the x-intercept, we let y equal 0, right? So we let y equal 0, so we're going to cover the whole y, because -4 times 0 will give us right, 0. Then in our heads, we can divide both sides by 3, so x equals to 4. So we got 4, 0. And to plot it, we're going to plot it over here, 4, 0. That'll be my point. And then to find the x-intercept, right, we let x equal 0. To find the y-intercept, we let x equal 0 and solve for y. So again, we're going to cover the whole x, because if x is 0, 3 times 0 will give us 0, so we can cover that. So in our heads, we can divide both sides by -4. So the answer will be -3, because 12 divided by -4 will be -3 for the y, which the point is 0, -3. So let's plot 0, -3. So it's going to be down here. And we just connect the points. So that's my line. And again, this is covered by using the x and y intercept, but I like to say the cover, okay? Because you cover one and you cover the other one to find the x-intercept or the y-intercept, and vice versa. But this is called graphing by using the x and y intercept. Okay, now how do we find the slope given 2 points? So this is a formula for the slope. It's y2 minus y1 over x2 minus x1. So for example, number 13, they want you to find the slope passing that passes through 9, 0 and 12, 12. So we're gonna right. So this is a first point. I'm gonna call this x1. X1 will be my 9. Y1 will be my 0. X2 will be my 12, and Y2 will be 12. So let's plug them into the formula. Y2 is 12, Y1 is 0. So it'll be 12 minus 0 and 12 minus 9, which will give us 12 over 3, which will give us 4. The slope is 4. Let's do number 14. The line through negative 5, negative 2, and negative 4, 11. So again, the same way. We know that x1 is negative 5, y1 is negative 2, x2 is negative 4, and y2 is 11. We'll plug them in. So this becomes 11 minus negative 2 will give us 13. And on the bottom is going to give us 1. So 13 over 1 will give us 13. Okay, now I also share with my students that when you're given two points, right, and they want you to find the line going through the 2 points, I always tell my students to observe both points. If the x's repeat, the line will be undefined, the slope will be undefined, and if the y's repeat, it's going to be 0. Okay, so let's put those what I just said, those statements into action. And here's the reason why. My x1 is 5, my y1 is 3, my x2 is negative 7, and my y2 is 3. If we notice, right, the 3's repeat on the y's. So if we plug them in, right, it's gonna be 0 because we have 3 minus 3, it was gonna give us 0. So it'll be 0 over negative 12, the slope will be 0. And again, what was the observation? When the y values of the 2 points repeat, it'll be 0 slope. Because if the y's repeat, right, and the y's are in the numerator, 0 over any number will give us 0. And also similar for for number 16, right? But now the x's will repeat. We have x1 is 1, y1 is 2, x2 is 1, and y2 is negative 6. If you notice, the x's repeat, right? So the x's will cancel at the bottom. It'll be 0 because negative 1 minus 1 will give us 0. But in the numerator, we got negative 6 minus 2 will give us negative 8. So when you have a 0 on the denominator, it's going to be undefined. So my slope is undefined. So what's my observation? My observation, when the x values of the 2 points repeat, the slope is undefined. Okay, now it says this is a point slope form, which is y minus y1 equals to mx minus x1. You need the slope and 1 point to find an equation of a line. So here, guys, they give you a point and a slope. So let's put this equation into action. This form, this point slope form. So, right, we know that x is negative 3. x1 and y1 is 2, and my slope is going to be 4. So all we do is plug them into the formula. My y1 is 2, my slope is 4, and my x1 is negative 3. So here, guys, x minus negative 3 will give us an x plus 3. Now we have to distribute. So we have 4 times x, and 4 times 3 is going to be y minus 2 equals to 4x plus 12. Now we're going to add 2 to both sides. So we have 4x plus 14. This is the equation of the line in slope-intercept form. Here's another one. So again, right, if we do the observation, right, we know that the x's and the points, they do not repeat, and neither do the y's. So we can go ahead and use a formula. But here, guys, they don't give you the slope. We need to find the slope first. So that's why we have to use the slope formula. right? So we have x1 is negative 5, y1 is negative 2, x2 is negative 4, and y2 is 11. So we plug it in. So 11 minus negative 2 and negative 4 minus negative 5. So we get 13 over 1, which is 13. Now, right, my x1 was negative 5, and my y1 was negative 2, and my slope is 13. So we plug it into the formula. So we're going to have y minus negative 2 equals to 13x minus negative 5. So this simplifies to a plus, right? So this will be y plus 2 equals to 13 plus 5. Now we get to distribute 13 times x and 13 times 5. So we have y plus 2 equals to 13x plus 65y, because 13 times x will give us 13x, and 13 times 5 will give us 65. The next step, we subtract 2 to both sides, from both sides. So it's going to give us y equals to 13x plus 63. So this is the equation of the line in slope-intercept form. Now, we're going to be discussing parallel and perpendicular lines. Two non-vertical lines are parallel whenever they have the same slope. So if two slopes have the same, they're considered parallel lines. And perpendicular lines means they have the opposite reciprocals, or if you multiply them, the two slopes, it should give you -1. This is what it means here. Two non-vertical lines are perpendicular whenever the product of their slopes is -1. Or an equivalent definition of perpendicular lines is a non-vertical lines whose slopes are negative reciprocals of one another. I'm going to show you an example of each one. Examples of parallel lines. For example, here my slopes are both 3. So they're the same. So these two lines are parallel because both slopes are 3. Here, both slopes are -2. Right, so they're parallel. These are examples of perpendicular lines. You see, for example, we have 3, right? This is 3 and this is -1/3. By the definition, the opposite or the negative reciprocal means, right, or the opposite reciprocal means if it's positive here, it's going to be negative. And then 3 is the same thing as 3 over 1. So we use a reciprocal. The next example is a little bit more understanding, right? This is the opposite reciprocal, so you multiply them, and it's going to give you -1. Okay, now, you see we have 4/5 and negative, right? This is 4/5 and this is -4/5, right? This is 5/4 and -4/5. So if you notice, 5/4 and -4/5 are negative reciprocals of each other. And if you multiply them, it'll give you -1. So these are perpendicular lines. Okay, now, finding equations of lines. Find the equation of the line with a given condition through the point 3, 4 and parallel to 4x minus 2y equals 5. So in this case, I need to, for the solution, I need to find the slope of the 4x minus 2y equals 5 line. So I need to rewrite it in slope-intercept form. And after I do that, I use a Poisson formula to find the equation of the line. Okay, here we go. So I need to rewrite it. So I'm going to subtract 4x to both sides. Then I'm going to divide -2 by every term. This becomes y equals to 2x minus 5 over 2. So my slope is equal to 2, right? So we have to find another line that's parallel and is to this line and is passing through the point 3, 4. So remember, parallel lines have the same slope. So I got my slope and I got my point. My point is x, right? X will give us x1 will give us 3 and y1 will give us 4, and my slope is 2. So we plug him into the y1, to the x1, and to my m. Right? My y1 is 4, my slope is 2, and my x1 is 3. Now we distribute on the right side. So we get 2x minus 6 on the right side. Now we can add 4 to both sides. So it's going to give us 2x, y equals to 2x minus 2. So this is the equation of the line that we're looking for. Now, I have another method to show students. Okay? Instead of using the slope, the Poisson formula, we can use another formula to find my b, because I already have my m, right? I already have my m, I need to find my b. So we're going to use b equals to y minus mx to find b. So this is my x1, y1. So my y is 4, and my x is 3, and my m is 2. Plug them in there. So 4 minus 6 will give us negative 2. I like to show different ways to get the solutions, write the answer, and this most students like better this way because it's less work. Okay, but you can use it either or, you get the same answer. You see, we got the same answer, the same line. That's what we did here on top. So y equals to 2x minus 2 is your line that we're looking for. Okay, now they want now we're going to do something similar to the last slide, but the thing is now they want the passing to the 0.68 and perpendicular to the given line, which is negative 2x plus y equals negative 3. So again, we have to rewrite the equation of the line, the negative 2x plus y equals negative 3 in proper form. So we add 2x to both sides. So we get y equals to 2x minus 3. Okay, now here, if it was parallel, right, we use the same slope, which is 2, but for perpendicular, it's the opposite reciprocal. So my slope here is 2, so the opposite reciprocal, or the negative reciprocal, will give us negative 1/2. So this slope is perpendicular to the 1, to the 2, to this slope here. So I got my point, right, and I got my slope. And my slope is negative 1/2, so all we do is plug him in. Now we distribute. This will give us on the right side negative 1/2 x plus 3. We add 8 to both sides. So 8 plus 3 will give us 11. So it's going to give us y equals to negative 1/2 x plus 11. This is a line that we're looking for in slope-intercept form. Okay, now, how are linear equations applied in real life? Okay, I like to use this example here. It says, the manufacturer suggests the retail price of the MSRP for a base model 2016 Toyota prices is $25,035. And it is expected to be worth $14,115 in 4 years. So for A part, it says find the linear depreciation function for this car and estimate the value of the car in 5 years from now. And see at what rate is the car depreciating. So solution, we need to find 2 points. And then once we get the 2 points, to find the equation, we do what we did in the previous slides. But from the word problem, we have to extract or get the info to get the 2 points. So when the car is brand new, right, in 2016, the car is brand new. So that means that the original price, when x is 0, the original price was $25,035. So when x is 0, y is $25,035. So it'll be 0, $25,035. And then for the next point, right? So in 4 years, it was worth 14,115. So with the information, when the year is 4, x is 4, and y is 14,115. So we got our second point. Okay, now we're going to we need to find the slope and the y-intercept. So to find the slope, we use the formula, the y sub 2 minus y sub 1 equals to x2 minus x1. So this is my y2 will give us a 14,115. and my minus the y1 will give us 25,035. My x2 is 4, and my x1 is 0, so 4 minus 0. So we get negative 10,920 over 4, which will give us negative 2,730. So that's my slope. Now, to find the b, right, I like to use this formula instead, the one that I mentioned earlier, or that I used earlier. So b minus, so the b equals to y minus mx, I'm going to use the first point. So my y is 25,035 minus my slope, which is 22,730, and my x is 0. So b is equal to 25,035. You could have gone the same b by using the second point, right? So for the second point, you can also use it, but the easier point to use is the first point. That's why I chose that one. Okay, now, so what's my equation? There's my slope, and there's my b. So plug him in. So that's the equation of the line that they're looking for part A. So the final linear differentiation function, which is f of x equals to negative 2,730x plus 2,500 plus 25,035. This is the answer, the equation for A. Now for B, estimate the value of the car in 5 years from now. So for B, we're going to evaluate f of 5, which means I'm going to go to the original function and plug in 5 for every x. We just evaluate. So it's going to give us 11,385. So for B part, the car will be worth in 5 years when it was purchased will be 11,385 in 5 years. Now for C part, at what rate is a car depreciating? So here, guys, depreciating, it means it's already going to be negative, right? So we don't have to put negative 2,730. We just put the positive 2,730. The car is depreciating at 2,730. And again, we don't put negative because depreciating means negative. So anyway, this is the answer for C. And this is how you apply a linear problem in real life. Now we're going to be doing evaluating functions. For evaluating functions, all we do is plug in, for example, if we're doing f of negative 2, all we do is we're going to plug in negative 2 for every x. Okay, so it's going to be negative 2 there, and also for the negative x's. And now we evaluate it, so it's going to be 4 plus 2 plus 4 will give us 10. So f of negative 2, the solution is 10. Now for B part, find f of 3, we're going to plug in 3 for every x. This is supposed to be, I put 3 here, guys. This is supposed to be 5, guys, not 3. Okay, my bad, I did a mistake here. It says f of 5, so we plug in 5 for every x. So we're going to plug in 5 there and 5 there. It will give us 25 minus 5 plus 4. The answer will be 24. Okay. Now, I evaluated at f of x plus h, which means I'm going to plug in x plus h for every x. I'm going to plug it in there, so x plus h minus x plus h. So here on the right side, I'm going to evaluate x plus h squared, which here, guys, we're going to do the follow. So x times x will give us x squared. X times h will give us xh. And h times x will give us xh. And h times h will give us h squared. The two in the middle terms can be, they're considered like terms, so we can add those. So xh plus xh will give us 2xh. So this will give us x squared plus 2xh plus h squared. That's this part here. Minus, so this will be minus x plus h, right? So now to simplify it, this will be x squared plus 2xh plus h squared. Then we have negative x, negative h, because negative times a positive h will give us a negative h plus 4. Now, guys, this is doing the difference quotient. if you're taking calculus, if you're taking not calculus, or yeah, business calculus, which is at 1325, you're going to see this again. Okay. So first, right, first find x plus h. And again, right, we're going to plug in x plus h for every x. So x plus h squared, right? I'm going to do it here on the right side again, like before. There's going to be x squared plus 2xh plus h squared. And then minus x plus h plus 4. So then it's going to be x squared plus 2xh plus h squared. Negative times positive x will give us negative x. Negative times positive h will give us negative h plus 4. Now, again, this one we're going to do it in 3 steps. This is my first step. Now, my second step, I'm going to do the whole numerator, which will be the f of x plus h minus f of x. The f of x, the function, is already given, right? This is my f of x, the x squared minus x plus 4. So this whole expression is my x plus h minus my f of x, which will be minus x squared minus x plus 4. So we just bring the f of x plus h down, and then here all the signs inside the f of x will change because of the negative here. So negative, that'll be, this is positive, that'll be negative. That's negative, that'll be positive, because negative times a negative will give you a positive, and negative times a positive 4 will give us a negative 4. Now, we begin to combine terms. I like to tell my students that in this case, only the terms that don't have an h will be able to cancel. For example, the x squared, right? So the x squared doesn't have an h, so there's going to be a negative x squared somewhere, and here it is, right there. So then the terms without an h will be eliminated. For example, x squared doesn't have an h, so we have x squared, and here we have negative x squared, so they'll cancel. The second term, right, it has an h, so that's going to stay. And also, a squared has an h, it's going to stay, right, because there's no other like term that we can add them or subtract them. The negative x, right, we have a positive x over here on the right, so they'll cancel. The h, right, there's no h by itself, so the h stays, and the 4 will cancel because over here at the end we have a negative 4. So this is what's left. Now we're going to factor out an h. Why do we do that? Because we want to cancel this h with the 1 on the denominator on the formula. So now comes the step 3, right? So this is the f of x plus h minus f of x, which will give us h times 2x plus h minus 1, right? And the h is h divided by h will give us 1, right? So 1 times 2x plus h minus 1. So this is my solution, the 2x plus h minus 1. And again, this type of problems, the different quotients, you'll see it again if you're taking the next math course which is a 1325. Okay, now for these type of problems, guys, we want to find the vertex, axis of symmetry, y-intercept, and x-intercept of the function. And at times, they also want you to graph it in Mymathlab, right, for the homework and stuff. So now, here's the solution, right? If it's in this form, in ax squared plus bx plus c, this is how you find the vertex. Negative b over 2a, and f of negative b over 2a. At times, this seems a little bit intimidating to some students. All this means that once I get the x value, right, which is a negative b over 2a, I plug it back to the original to find the y value of the vertex. Okay, right now I'm going to show you how it's done. And then the axis of symmetry will be the x part of the vertex, or it'll be the negative b over 2a. For the y-intercept, right, it's also obvious. It's also like you can observe that this, without doing the work, you should know also what the y-intercept is. It's going to be 0c, which will be my 9. And for the x-intercepts, you have to know how to factor. Okay, now let's find the vertex. So we have to know what the a is. My a is 1 and my b is 10. So let's plug him in there, right? So my b is 10 and my a is 1, so this is going to give us negative 10 over 2 will give us negative 5. So my x part of the vertex is negative 5. Now to find the y part, we're going to evaluate the function at negative 5. That means I'm going to plug in negative 5 where the x is, and also where the x here where the 10x is. And then all we do is simplify. We get negative 16 because negative 5 squared is 25. 10 times negative 5 is negative 50. So 25 minus 50 will give us negative 25. Negative 25 plus 9 will give us negative 16. So my vertex will be negative 5, negative 16. Okay, now, once you found the vertex, you also found the x-axis symmetry. The x-axis symmetry will be x equals to the x part of the vertex, which will be negative 5. So the x-axis symmetry will be x equals to negative 5. My y-intercept is my 0c. My c is a 9, so it's going to be 0, 9. Okay, that's my y-intercept. Okay, now for the x-intercept, right, we let y equals 0, and we have to factor. To factor, the signs here, guys, are going to be the same. Right, so this is how you factor, but I believe I'll be doing another presentation on factoring perhaps next week, okay, on how to factor. So x squared plus 10x plus 9 is equivalent in factor form to x plus 9 and x plus 1. Then we apply the zero property theorem, which if x plus 9 times x plus 1 equals 0, so either one of these two will be 0 or both have to be 0. So how do we solve for it? We let each binomial equal to 0. So on the one on the left, we subtract 9 to both sides, right? So x equals to negative 9. And the one on the right, we subtract 1 to both sides, so x equals to negative 1. So these are my both x-intercepts, negative 9, 0, and negative 1, 0. Okay, now, and also, guys, let me go back real quick. And guys, to graph it, all you do is plot out those points, and you'll be able to graph the parabola. Okay, because a quadratic is always a parabola. That's how you graph it. Okay, by plotting all the points. Okay, now this is also a quadratic equation, but this is called in vertex form. So if it's in this form, right, in the f of x equals to a parentheses x minus h squared plus k, the vertex is hk. The x-axis symmetry will be x equals to h. For the y-intercept, you're going to let x equal 0 and solve for y. And for the x-intercept, you're gonna let y equal 0 and solve for x. Okay, so let's do it. So my vertex, if you notice, the vertex here is positive, right? It's positive 3. So if my vertex here is negative and it's h, it's going to be negative 3, negative 16. This is my vertex. Okay, it's always the opposite of what's here on the parentheses. Because the formula is x minus h, and the slope and the h is positive here, right? So in other words, it's always the opposite of what's here. If it's positive, it's going to be negative 3. If it's negative, it's going to be positive. So this is my vertex, negative 3, negative 16. So what's the x-axis symmetry? It's going to be x equals to h. My h is negative 3. So it's going to give us x equals to negative 3. Okay. Now, for the y-intercept, g of x is also the same thing as y. So I'm going to plug in 0 for the x, right? Because that's how you solve for the y-intercept. So we're going to plug in 0 for x. 0 plus 3 will give us 3, right? Plus 3 squared is 9. 9 minus 16 will give us negative 7. So what's my y-intercept? 0, negative 7. Now for the x-intercept, we're going to let y equal 0 and solve for y. So here, guys, the first thing we're going to do is we're going to add 16 to both sides. So we have 16 equals to x plus 3 squared. Now we're going to square root both sides. You notice, guys, I put the x plus 3 on the right side, and I put the 16 on the left side, and we square both sides. Because most of the times, what we're looking for is on the left side. So that's why I switched them here. Or perhaps I should have done that step first. Okay. Now, right, so the square root cancels the square. So on the right, on the left side, we have x plus 3. But on the right side, we have plus or minus 4 because the square root of 16 is 4. Every time that you take the square root of something, guys, it's going to be plus or minus. If you take the even root, it'll be plus or minus. And then we're going to subtract 3 to both sides. So we have x equals to negative 3 plus or minus 4. So we have negative 3 plus 4 and negative 3 minus 4. So we have x equals to 1 and x equals to negative 7. So it's going to be negative 7, 0, and 1, 0 are my x-intercepts. And if you were graphing them, all you do is plot all the points and connect them, and you have a parabola. Now, I believe this is the last problem for today because it's almost time. Yeah, we have a minute. This is how you apply quadratic equations or functions in real life. It says here, hey guys, here on the problem, guys, it should be from 2010 to 2015, right? It's like a miss. I made a mistake here. It's supposed to be 2010. The revenue for McDonald Corporation in billions of dollars for the years 2010 to 2015. And I repeat, this is supposed to be 2010. The quadratic function r of x equals to negative 1 half x squared plus 13x minus 57, where x equals 10 corresponds to the year 2010. So this has 3 parts. The first part, they want you to find the vertex. For the second part, it's supposed to be in what year, okay? Is that this supposed to be in what year? In what year during this period was the revenue at a maximum? And for part C, what was the maximum revenue to the nearest $1 billion? So when we find the vertex, we also found the answer for B and C. Let me show you or explain how that is done. Okay, so the first thing we're going to do is find the vertex. So I have to know what the A is and what the B is. My A is negative 1 half or negative 0.5, and my B is 13. So plug it into the formula to find the x part of the vertex. So it'll be negative 13 times 2 times negative 0.5. It's going to give us 13 over 1, which is 13. Right, so that's my x part of the vertex. For the y part, we evaluated at 13, the original function. So I'm going to plug in 13 for every x. So I'm going to plug in here for the x and then the squared and the 13 times 13. So if we put that in the calculator, guys, it's going to give us something like 27.5. So guess what? That's my vertex. 13, 27.5. So now, once we found, right, the vertex, we also found with the vertex, we can find parts B and C. So for part B, it says in what year during this period was the revenue at a maximum? So if x equals 10 corresponds to the year 2010, so then x equals 13 should correspond to the year 2013. So the answer will be 2013. Now for C part. So in 2013, the revenue was at a maximum. For C part, what was the maximum revenue to the nearest $1 billion? So the y part of the vertex is going to be the maximum revenue, right? The y value of the vertex. But they want you to round off, right, to the nearest $1 billion. So the maximum revenue is $28 billion. That's the answer for A, B, and C. And I believe that's it for today's PowerPoint. Okay.
Let me just give them a few announcements, Mr. Isasi.
Okay, Mil, go ahead.
Okay, so for next week, for Math 1324, we're going to be having factoring exponential functions into logarithmic form. And just once again, thank you, Mr. Isasi, for presenting today. And thank you, James, for being here today with us. And have a good weekend, and we'll see you next week.